Hello class, Math 1440. We're doing section 7.4, improper integrals. Notice the syllabus skips section 7.3, so do not concern yourselves with 7.3. That will not be on any test. Okay, so I'm just going to do one problem today. This is called an improper integral because we see an infinity symbol as one of the limits. So evaluate the improper integral from negative infinity to 0 of e to the 3t dt. So whenever you have an improper integral, where at least one of these limits involves infinity or negative infinity or both, you want to rewrite it as a limit. So this integral is going to equal the limit. And then you can choose any variable you want. I like to think of these limits as from a to b. So I'm going to write the limit as a approaches negative infinity of the integral from a to 0 of e to the 3t dt. We're so used to x, but you don't always have to use x. So instead of e to the 3x, this problem is e to the 3t. Since the variable is t, we write dt. Not a big deal at all. So notice, because we're using a limit, we don't deal with infinity signs in our limits of integration. So that's step one. And then you want to make sure you carry this limit until you actually evaluate the limit. So you want to have good form. So I'm going to write this is equal to the limit as a approaches negative infinity. And now, the first step when you're evaluating an integral, which has limits of integration, is just find an antiderivative. So I'm going to do it the shortcut way. The integral of e to the 3t is just going to be e to the 3t over 3. That is the indefinite integral, or the antiderivative, by the shortcut way. Now that I have my antiderivative, we're going to evaluate from a to 0. Notice, with the derivative is different. The derivative of e to the 3t is e to the 3t times 3 by the chain rule. But the antiderivative, you divide by the 3. So if you don't like to memorize that shortcut rule, here's the long way to do it. Do a u substitution. Let u equal the exponent. If you let u equal 3t, and then do a u substitution, next step you would find du dt. The derivative of u with respect to t is 3. And then from here, there's different styles. I always solve for dt myself, and then rewrite the integral using the substitutions. And then after you do the u substitution, you're going to get exactly this answer. So again, you can check it on your own, because I know everyone seems to do it a different way with the u substitutions. There's like 3 or 4 different styles. Okay, so ultimately you will get this as your antiderivative. And notice, you always want to make sure that your little variable occurs in pairs. I chose A. You could have chosen B or X or R. It doesn't really matter. So whatever variable you want. I chose A. So notice, I have an A here, and there's an A here. So this A makes no sense unless you see another A. So just have good form. Always make sure that this letter occurs in pairs. So there's a pair of A's. Here I see an A. And here I see an A. So the A's occur in pairs. So that's a good sign that you're doing things correctly. Equals. And now this 3 on the bottom, you think of it as a 1/3. By property of limits, I can pull the 1/3 in front. I can either put it right here, or I can put it actually in front of the whole limit notation by property of limits. It doesn't really matter. I like to pull it all the way out front. So if you check out the notes on Learn, you'll see, properties of limits as review. So this is the same thing, writing 1/3 the limit as a approaches negative infinity of just e to the 3t. And again, we're evaluating from a to 0. So here again, the a's occur in pairs. That's a good sign. Okay, so this is now going to equal 1/3 the limit as a approaches negative infinity of, and now we do the evaluation. Always input the top limit first. So this is going to be e to the 3. If I let t equal 0, 3 times 0 is just 0. So I'm just going to write e to the 0 minus, always minus, and then you input the lower limit. When I let t equal a, I'm going to end up with e to the 3a. If you want to put parentheses, that's optional. So I'll do that. Every limit needs an input. Okay, and now we're ready to evaluate this limit. So drop the limit notation for your next step. So again, the a's occur in pairs or they disappear together. So you'll either see 2 of them or none of them. So this is going to equal 1/3 times, and the limit of a constant isn't e to the 0 just 1. Anything to the 0 power is 1. So the limit of a constant is always going to be that constant. That's a property of limits, which you'll see in the notes on Learn. So the limit as a, there is no a here. So the limit as a approaches negative infinity of 1 is just 1 minus, and now the limit as a approaches negative infinity of e to the 3a, that's going to be 0. And then we get 1/3 times 1 minus 0 is 1. 1/3 times 1 is 1/3. So this limit converges. It converges to this real number of 1/3. Sometimes, like if you look at the notes again on Learn, you're going to see an example where the limit diverges because you get infinity or negative infinity for an answer. But in this case, because we have a real number answer, we say the limit converges to 1/3. So some of you are probably saying, how did I get this 0? So let me do that more carefully now. As a approaches negative infinity, e to the 3 times a, that really, think of it as this, e to a negative huge number. Negative huge number. Because as a approaches negative infinity, that means you can let a be as large as you want in the negative direction. So a positive 3 times a negative huge number is just going to be some negative huge number, as huge as you want. And by the rule of exponents, if you have a negative exponent, you can write that as 1 over e to a positive huge number. You can think of this as, this is just, I'm not being too mathematical here. I'm just trying to give you an intuitive feel of what's going on here. And when your denominator is really, really huge, as big as you want it to be, then we say the limit of that expression is 0. And again, that's in the notes. So the limit is going to be 0. So your final answer is 1/3. Okay, so that's it for 7.4, and I'll talk to you next time. Good night, everyone.